Greetings, everybody. This is the first of the 3 videos that hopefully will explain how you will do lab number 2, which is projectile motion. I'm going to post a sheet of equations, and notice here that these are the equations that apply to sheets 1 and 2, and then down here, this is the equations that apply for sheet 3. Um, and what I'm going to do is I'm going to post, as I said in the announcement, to keep the videos to a manageable size. I'm going to post, a video for sheet 1, a video for sheet 2, and a video for sheet 3. So what you'll do is you'll have the template, and this is it right here. Obviously, where it says name, type your name in it. So I'm going to type in, Dr. Gomez. And then notice some of the values are already filled. Some of the calculated values are already filled out. Actually, we'll get to that in a minute. Let me explain. So what you do, here's the link to the simulation. So let's figure out how to get that open. I'm going to pause for a second. Yeah. So let me just backtrack. So here's the link to the simulation. And you just click in cell J2, and it'll bring up the simulation. Projectile motion, you got intro, vectors, drag. We go to lab, and click on it twice, a second time. Now here's the simulation. And now go to the Excel file, and notice for sheet 1, here's our initial speed and our angle. And notice for sheet 1, we want to set yi, the initial height, to be 0, and xi for projectile motion. Xi is always 0, but yi does not have to be 0, but xi will always be 0. And we'll get to the rest of the spreadsheet in just a second. So let me go back to the simulation. And let me go ahead and, what did I want? I want an initial speed of 15 meters per second and an angle of 25 degrees. And I want, again, xi will always be 0, but in sheets 1 and in sheet 2, it'll turn out I want yi to be 0. So 15, 25. All right. So I want the angle to be 25. I'm rotating the cannon. You can see the angle's changing, 25. And I said 15 for the initial speed. And I say in the simulation, I think I say use a baseball. As you know, the projectile motion equations are independent of mass, so it doesn't matter. But I'm going to go ahead and choose a baseball. And I want to use 9.80 for gravity. They have 9.81, so see I changed it over here. Now, the position of the target doesn't really matter. It's just sort of fun. You notice when you press the fire gun, I want to move right there. I know the maximum range of the projectile for these initial values, an angle of 25 and a VI of 15 meters per second. The range, the max range is 17.6 meters. Now notice on the projectile, you have here these dots. Well, those represent the various time intervals. Now what you want to do in the spreadsheet is notice everything right now, this first row, everything is 0. And what you want to do is you want to then fill out all these values for all these successive times. But we'll get to that in a second. Let me go to this section right here. Well, notice I've calculated this row right here, row 8. I've calculated the total time of the projectile, meaning the total time that it's in the air, the time from beginning to when it hits the target. So I've calculated T total. Now T max, that's the time at the max height. That's the time at this green dot right there. That's the max height of the projectile. I've gone ahead and calculated that time. Now what is Y max? Well, Y max is the maximum height of the projectile. That's the height at this green dot. Y max is the height at T max. Well, how did I calculate those? Well, if you go to the Word file that has the equations, um, the total time is that's the time it takes from start to end. Well, the total time is derived like this. Well, we know we have projectile motion equation 2, yf equals yi plus vyit minus 1 half gt squared. Well, remember, in sheets 1 and 2, y initial is 0. Well, when it lands, what's y final? Well, when it lands, y final is also 0. So again, that's why in the next equation, yf and yi are 0. And remember, what is vyi? This is very important. Vyi is vi sine theta. Now, what I want to do is I want to solve this equation for t, and it's going to give me the total time, because that's when it starts at a height of 0, and the total time is when it lands, when y final is 0. So that's going to give me the total time. So if you solve this equation for t algebraically, you're going to get 2 vi sine theta all over g. And what I've done is I've taken this equation, this formula, and I've entered it in cell C8. That's right here. See, 2. Now, in Excel language, $f, $4, that's referencing cell F4 right here. Well, the dollar signs are telling me, in Excel language, that's saying do not change that cell reference. So $f means stay in column F. $4 means stay at F4. Because VI never changes. VI is 15. So that's why it's the $f, $4. Then it's the sign, and theta's not changing either. Well, where's theta? The value for theta is F in cell F5. So it's the sign, then parentheses, it's $f, $5. Meaning always use 25, always use cell F5. Then you have to multiply, you have to convert it to radians. Excel, when you do the trig functions in Excel, if you just type in 25, it's going to think it's 25 radians. But we're in degrees, so I have to convert to 25 degrees to radians. And that's why I have to multiply it by pi. And the pi with the blank parentheses, that's Excel language for pi. See, it's the 3 point. And then, click on it there. And then you have to divide by 180. So they're simply saying 25 times pi over 180. And then $C, $4, that's my value for G, 9.80. So that's why I've entered that formula for you. Now, what is T max? Well, T max is the time at the max height. Well, that's given right here. Remember, we're using projectile motion equation 3. Vy is equal to Vyi minus gt. But remember, at the max height, the speed is 0. So Vy is equal to 0 at the max height. So you have 0. Again, this is very important. What is Vyi? Vyi is Vi sine theta. So you have 0 equals Vi sine theta minus gt. In other words, that's the time at the max height. We call it T max. So T max is simply equal to Vi sine theta over G. I've taken that equation, and that's entered right here. See? Again, that's $f, $4, sine theta. That's my Vi sine theta. Remember, you have to multiply by the pi and then divide by 180. And the dollar signs mean it don't change that cell. $F, $4. That's meaning that's your VI. It's always going to be that cell, i.e. it's always 15. The $F, $5, meaning the angle is always 25. It's meaning always use cell F5. But I've just entered that formula, so That's VI sine theta all over G. And remember, G is in cell C4. That never changes. So that's why it says $sign C, $sign 4. So I get that the time at the max height, the calculated time, is the 0.646. Now, what is the max height? How do you calculate the max height? Well, go back to your Word file. The max height is, yeah, here, the max height it's this derivation right here. Because the y max, that's the height, that's y at T max, at the max height. So the derivations here, you end up with y max is yi plus vi squared sine squared theta all over 2g. But remember, for sheets 1 and 2, yi is 0. So the max height is simply vi squared sine squared theta, or equivalently vi sine theta parentheses squared all over 2g. Remember, in sheets 1 and 2, yi is 0. So I've entered that formula here. It's actually in Ka, but see, that's my yi, $sign I, $sign 4, that's my yi, but in this case it's 0. And then notice it's vi sine theta squared. That's my $sign F, $sign 4, sine, you know the drill, sine, $sign F, $sign 5 times pi over 180. But notice then it's squared. That's Excel language for square it. Oops, I gotta quit doing that. And then divided by 2g, 2 times $sign C, $sign 4. So all I've done is I've entered this formula in sheets 1 and 2. It's in K8, but I've entered that formula in that cell. And remember, in sheets 1 and 2, yi is 0. But yi is in $sign I, $sign 4. The reason I did this is if for some reason, suppose I wanted to run it sheets 1 and 2 with a different yi, I could just change that, and I don't have to go ahead and change the formula. So those are the calculated values. Now notice the percent errors are, I don't know why it's 100% here. It should be nothing. But anyway, those will update automatically when we add the simulation values. So anyway, so you're looking at something like this. All right. Again, where did I get those calculated values from? Right here. Y max, T max, and then and T total. Yeah. So they're all right here. Okay. Now what do we do? What about all these other columns? Well, what we want to do is we want to compare the x and y values that the simulation gives us along the trajectory with the values that we actually calculate. We'll do the calculations in Excel, but they're the values we calculate using the projectile motion equations. Which are here. This is x is vxi times t. What is y? Y is y initial plus vy initial t minus 1/2 gt squared. Again, very important. What is vxi? Vi cosine theta. What is vyi? Vi sine theta. So again, I've taken the projectile motion equations and I've noticed right here, notice in this cell, that's vxi times t, i.e. that's vi cosine theta times t. Remember, $sign F, $sign 4, that's my vi. Okay. Cosine of $sign F, $sign 5 times pi over 180, that's the cosine of theta. And then B15, notice that's the B column. B15 is where the first time is. Likewise, this is entering. Then again, that's my yi plus vyi t, which is vi sine theta times t minus 1/2 g t squared. My t, the first t value, is in cell B15. So I've entered those formulas. Now, what do we do with them after this first row? Well, we'll get to that. Okay, so now first thing we have to do is, everything comes out to be 0 in the first row. Now, what about the next time? Well, how do I go ahead and fill out um, B16, and then how do I do XSim and YSim? How do I get these values? Well, they're from the simulation. So what you do is you go back to the simulation. I've already fired it. Now here you have this crosshair. Well, what you do is you take this crosshair and you put it over each of the subsequent dots. See, there's a dot here, a dot here. So I'm going to go ahead and put this. And when it lights up, it's disco, which means you're there. Now here my time is 0.1. The range is x. So that is the x value from the simulation. That is xsim. The height is y. That's the ysim. So notice it's 1.36 is x and 0.58 is y. Let me go ahead and enter them in. 1.36 and 0.58, and I know the time was 0.1. How do I know that? Just go back to the simulation. So I'm just taking the cross. See, time xsim ysim. Time xsim ysim. Now notice we're going to do a percent error between the values that Excel gives us and the values that the simulation gives us. Notice right now it says divide by 0. Well, don't worry about that. We'll get to that. Now let me pause this. And now what I'm going to do, well, I'll pause in a second. Now I'm going to take the crosshair, go to the next time, the next dot. When it's yellow, and notice I'm at 0.2 seconds, and I'm at 2.72 and 1.07. So here I'm at 0.2. Then my x value is 2.72. X is the range. So that's 2.72. The y was 1.07. Okay, oops, I had a backslash. 1.07. Okay, click down. Oh, I entered my time incorrectly. Darn, hold on. 0.2. Okay, now I'm going to pause the video. I mean, you get the idea. Notice we have to go all the way. So, and now here, right here at the green dot, that's the max height. So that t, that time, right there at that green dot, that's the max height of the projectile. So according to the simulation, the time at the max height is 0.65. The range, i.e. the x value at the max height, is 8.79. The max height is 2.05. Then notice when you go to the target, when the projectile lands, the total time is 1.29 and the range is 17.59. Of course, the height is 0. And so what I'm going to do is I'm going to pause the video and go ahead and, well, actually, I'm not going to pause it. I'm just going to go to 0.3. So now let me go to 0.3. So my time is 0.3, 0.3. My range, which is x, is 4.08. And the y value at 0.3 seconds, the height at 0.3 seconds, is 1.46. And you get the idea. So you just keep going. You're going to go, 0.4. It's a tenth of a second, except when you go, notice you're going to go 0.6. Then, now here, remember, this is the max height. The green dot is the max height. Notice, according to the sim, the time at the max height is 0.65. You go ahead and right here, according to the sim, see Tmax sim, type in 0.65. When you click outside, watch what happens to the error. It updates itself. Now, what is Y max according to the sim? Well, Y max according to the sim, that's the height. That's 2.05. Go ahead here, 2.05. Click outside. The error updates itself automatically. Now, what about the total time according to the sim? Remember, we calculated it using Excel. Well, what is the total time according to the sim? Well, just go over to when you hit the target, right there when it's yellow, 1.29. So go ahead, according to the sim, the total time is 1.29. Click outside, error, see now everything's good. Then you go back and now we need to do, 0.4, 0.5, 0.6, 0.7, all the way till the end. So, you're going to go to, 0.4, 0.5, 0.6. We already did the max height, go to 0.7. Your range is the X sim, the height is the Y sim. So you go ahead and fill those all out. I won't do it now because I've done the first three. You get the idea. Now, what about this? Well, notice I've typed here, remember, now the Excel columns, those are the calculated values of X and Y according to the projectile motion equations given here on the sheet. Well, I closed it. Oh, well, I need it. Well, notice I've typed in the formula for X here and the formula for Y here. What you do is you simply take this formula and drag it down. See that? Here. See that little square in the lower right-hand corner? When you get a crosshair, you copy it down. Notice what it did to the percent error. It changed it. Well, again, the percent error, you've got to take that formula, drag it down, and the percent errors are not, again, you can see here the X sim is 1.36. The calculated X is 1.359. That's going to be a very small error here. For 0.2, X sim is 2.72. Calculated 2.7189. Here 4.08, 4.07. Likewise here, Y at 0.1. The sim value is 0.58. Calculated value here, Y sim, Y calculated, Y sim, Y calculated. And notice the percent errors automatically update themselves. So what you'll do is go ahead and fill in from the simulation, go ahead and fill in all the remaining values. Then go ahead and just drag, go to the cell, go ahead and just drag the formula. Once you get the correct, just drag the formula down. But you want to fill out the first three columns first, and then well, you can do it either order. It'll update itself automatically. Um, oh, here. And likewise for the percent error. Once you fill out these first three columns, go ahead and click here, and just when you get the crosshair, just drag them down, and then you're done. And that's how you complete sheet one. And again, where am I getting? This is a calculated value, calculated calculated value. This column is calculated. Where do I get those? Well, that's from the projectile motion equations, which for sheet one, I've entered them in for you. Right here. Again, that's the formula for the total time. These are the formulas where you calculate X and Y at each time. This is for sheet three. We'll get to that. This is the formula for T max, and this is the formula for Y max. So I've entered them in sheet one. I've entered them for you. Just copy them down. Alrighty, so that shows you how to do sheet one. Okay, let me save this video and then we'll go to sheet two.